Hi friends, how are you all? So last class we have discussed what does mean by electrolysis. So electrolysis means whenever generally the molecules and atoms are very strong in their bonding, but whenever they dissolve in any liquid, the bond become weaker, and for that weakened weakened molten liquid or molten state of that particular material, if you provide the electricity and those atoms separate themselves into cations and anions, and cations are moving towards cathode and anions are moving towards anode, so this is what we call as electrolysis. Now how much amount of cations are moving towards cathode and how much amount of anions are moving towards anode will be given by Faraday's laws of electrodeposition. Okay, Faraday is a great scientist and he has invented these laws. Okay, so let us discuss these laws, and the first law is Faraday's first law. So the Faraday's first law states that chemical deposition due to flow of current through an electrolyte is directly proportional to the quantity of electricity passed through it. Okay, so what does it mean by this? So the mass of chemical deposition has been given by the mass of chemical deposition has been given by the mass of chemical deposition has been given by the relation in which is directly proportional to the quantity of electricity provided. Electricity quantity of electricity passed through it. So what does it mean? So M is directly proportional to quantity of electricity is taken as Q. So now we can say that M is directly proportional to Q and M is directly proportional to current I passed for particular time t. And finally M is equal to capital Z capital I into T, where these terms are specifically mentioned, where I is the steady current, steady current in terms of ampere, T is the time, I mean how much time the current is passing through that material, and Z is the electrochemical equivalent. So this is the constant and it is electrochemical equivalent of the particular substance. Electrochemical equivalent. So this is the Faraday's first law. So it is simply the mass of chemical deposition is directly proportional to the quantity of electricity passed through it. So M is directly proportional to Q. So M is directly proportional to I into T. M is equal to ZIT. Okay. So these are the different just one relationship. So this come under Faraday's first law. Let's move on to the Faraday's second law. Yes, Faraday's second law. When the same quantity of electricity is passed through several electrolytes, the mass of substances deposited are proportional to their electro respective chemical equivalents of equivalent weights. Chemical equivalents or equivalent weights. So what does it mean? So this is very simple. Here Z is directly proportional to chemical equivalents. Chemical equivalents or atomic weights. So what does it mean? Actually, when the same quantity of electricity is passed through several electrolytes. For example, we have several electrolytes. This is one electrolyte. This is another electrolyte. Okay. And this is one more electrolyte. Then same electricity has been given. Maybe I have taken the same electricity, same quantity I have given to all the three. Yeah, if same amount of electricity has been given, then what is the mass of substances deposited? So how much it will be the mass of substances? So you can take this part as it should be capital Z is directly proportional to chemical equivalents of the substances. Okay, so this is the Faraday's second law, and we will going to solve the problems based on these two laws also. Okay, so these are very simple laws and very important laws. We will solve some problems in the tomorrow's class. Thank you so much.